Hello guys, in this video we are going to discuss the solution of the problem 2 smallest in every subarray. So let us look at the problem statement. The problem statement says given an array of integer ARR, the task is to find and return the maximum sum of the smallest and second smallest element among all possible subarray of size greater than 1. If it is not possible, then return -1. So for instance, if this is the array which is given to us, then first we have to list down all the subarrays. So these are the subarrays which we have, and within each of these subarrays we have to find smallest and second smallest element, and then we have to compute the sum. In this way we will be able to compute various sum, and then all we have to do is we have to compute the maximum sum. So the maximum sum in this case will be given by 11, and that is what we are returning over here. So that's the problem statement, folks. Now let us discuss the solution of this problem. So the solution of this problem rely on the fact that the maximum sum of the smallest and second smallest element will be given by the adjacent element. So because of which we don't have to look at any other element other than the adjacent element, and we will be able to come to our answer. So let us put it more formally. So what do I mean over here is, for all I where I is greater than or equals to 0 and less than n minus 1, all we have to do is we have to compute ARR I plus ARR I minus 1, and then we have to compute answer, which is just the maximum between sum and answer. So we just have to compute the sum of the adjacent element, and we have to compute the maximum such sum. So that's the general idea behind solving this problem, folks. Now let us discuss why this solution works. So for that, let us take some example. So let us say this is the array which is given to us, and within this array, let us say the answer will be given by the sum of these two elements, which is x comma y. So the answer will be given by x plus y. That is, x and y are the smallest element of some subarray whose sum is maximum. So remember, folks, over here the answer will be given by x plus y. Now let us discuss why the solution which we have proposed will work. So for the case where x and y are adjacent, in such case we don't have any problem. The solution which we have proposed will work. But how about the case where there exists some elements between x and y? So let us discuss the case where there exists some element between x and y. So if possible, let us assume that there exists some element between x and y. So a, b, c, d and x, and after x there exists some element. So let us say those elements are z0, z1, z2 and so on, and then there comes y, e, f and so on. So let us say this is the set which is given to us, and for this set as well, as we have assumed, our answer will be given by x plus y. So for this set also the answer is x plus y, which is our assumption. So let us take this subset. So let us say S is the subset which we have, or S is the subarray which we have, and S contains element x, z0, z1, z2 and y. Now let us investigate this case, and we want to find out the sum of the minimum and second minimum element of the subarray S. Now since we know our answer is x plus y, which simply means x and y are the minimum and second minimum, and if x and y are the minimum and the second minimum element of the subarray S, then what can we say about z0, z1 and so on? Then that simply means for all I, zi will be greater than x and y. So let me repeat this, folks. So over here we have assumed that our set is this. So this is the set which we have, and within this set we know our answer is x plus y. Since our answer is x plus y, that simply means x and y are the minimum and second minimum element. So x and y are the minimum and second minimum element of the array. Then that simply means all these zi's, which is z0, z1, z2 and so on, has to be greater than x and y. Now if this is the case, then that simply means from this set S, we will be able to deduce another subset S1 which contains just these two elements x and z0. So let us do that. Let us deduce a subarray S1 where S1 is equals to x comma z0. Since the length of this subarray is 2, then the minimum and second minimum element of the subarray S1 will be given by x and z0, in which case the sum of the minimum and second minimum element will be equals to, so let us call this sum as sum1, will be equals to x plus z0. Now with this, what we have come to a conclusion is we have two cases now. One, which is our answer, which is equals to x plus y. So to begin with, we started with this assumption. So let me go back. So we started with this assumption where for the given array A, the answer will be given by x plus y. And with our discussion, we also computed a sum, which is this sum, and this sum is equals to x plus z0. So let us write it down. So we also have another sum, sum1, which is equals to x plus z0. Now let us compare these two. So as we can see, answer and sum1 both contain x. So this x we can cancel it out. So the relationship between answer and sum will be given by y and z0. And as we have discussed, all zi's are greater than x and y. So that simply means y is less than z0. And what does this imply? Well, this simply implies that there is a sum as sum1 which is greater than answer, in which case this should have been our answer. So essentially what I'm trying to say over here is we came to a contradiction. And what is the contradiction? Well, the contradiction is there exists a sum1 which is greater than answer, and that should not be the case. So what does this mean? Well, this simply means that our assumption, so this was our assumption, which is if possible, let us assume there exists some elements between x and y. Then that simply means it is not possible that there exists some elements between x and y. Because of which, in order to get to our answer, all we have to do is we have to compute this sum, which will be given by ARR I plus ARR I minus 1, and then we have to compute the maximum sum. Folks, I know the proof is little bit tricky, so in case if you have any confusion which you want to clarify, feel free to use the comment section and drop your confusion over there. I'll try to address them. For now, let us proceed forward. So that's the entire discussion of solution, folks. Now let us discuss the pseudocode. So let us say we want to compute pair with max sum and an array is given to us. So the first thing which we are going to do is we are going to check the size of this array. So let us say the size of this array is less than 2. In such case, it is not possible to find the pair sum, because of which we are returning -1. Otherwise, we are going to take answer and initial value is equals to 0. Then we are going to iterate on the elements of the array. So for I in range of len of ARR minus 1. And then we are going to compute the sum. So sum, which will be equals to ARR I plus ARR I plus 1. And then all we have to do is compute the max. So answer will be equals to max of answer comma sum. And towards the end, we just have to return our answer. So return answer. So that's the pseudocode, folks. Now let us see how we have implemented this in Python and C++. So first, let us look at the Python implementation. If the length of the array is less than 2, then return -1. Otherwise, answer equals to 0. And then we are iterating on the elements of the array. And then we are computing answer, which is equals to ARR I plus ARR I plus 1 comma answer. And towards the end, we are returning answer. So that's the Python implementation, folks. Now let us submit our solution. So our Python implementation got accepted. Now let us look at the C++ implementation. So the C++ implementation is also the same, folks. If length of array is less than 2, then return -1. Otherwise, you compute the sum of adjacent element and compute the maximum sum, and towards the end you return that sum. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ implementation also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.